shades of sun in the afternoon.
Hi Mathematers, today we're going to learn about the area strategy, something we talked about a little in class. And since we didn't have class yesterday, I want to make sure you all are able to do this with any multiplication problem. So let's consider 23 times 15. We'd be able to think about this problem as a rectangle that's 23 somethings, feet, yards, miles, by 15 somethings. And if we find the area inside that rectangle, all the squares in there, we will know the answer to 23 times 15. In the interest of doing the easiest possible thing, we're going to divide the top dimension, the length, into two sections, a section that's 20 long and a section that's 3 long. And we know that altogether that's still 23 long. We'll do the same thing with the width and divide that 15 length into a 10 length and a 5 length. We could divide it any way we wanted. We could do a 7 length and an 8 length, or a 11 length and a 4 length, but we just divide in such a way that it's going to make our computation easy. Once we've divided that up, we now have 4 separate rectangles that are fairly easy to compute, to get the area of. Let's take a look at that big rectangle, and we'll notice that it's going to be 20 long, right along here, by 10 wide, right along here. So the area of this rectangle here is going to be 200 square units. It's interesting to note that I could create this model using the same place value blocks that we used when we were doing addition and subtraction. I would just use the tens blocks. They'd be 10 long, and I'd use 20 of them across, and I could create this as a concrete model, not just a representational model. So I'm going to go right ahead and find the area of all 4 of those rectangles. So if we take all those partial products, and we would call each of these partial products. They're partial products of the larger equation, 23 times 15. And we add them all together here. We're going to end up with 345. The area strategy leads directly into the partial products algorithm. And remember, an algorithm is something you can do automatically. So when we're doing the partial products algorithm, what we're actually thinking about in our head is the model we created using the area strategy. So we want to think in our heads about that rectangle that we created in the previous step. We want to think about the big rectangle. So that would be these two. Now remember, this guy right here is not 2, it's 20. And this guy right here is not 1, it's 10. This is one of the things about thinking about math with understanding. We have to give the numbers their proper values based on the places they're in. So there's the first rectangle, and that's the first that's the first partial product that we've been able to find. The next one we're going to look at, it doesn't really matter the order, you just have to be sure and get them all, is 10 by 3. And that, of course, gives us 30. Then we'll look at going the other way, the other sort of long, that was at the bottom of our rectangle, the long piece that was 20 times 5. And then finally, we look at the last two, the little rectangle in the corner, the 3 by 5. This is a way of solving a multi-digit multiplication problem without having to draw out all of the rectangles or all of the area model. But we keep the area model in our head. At this point, some of you may be wondering, okay, so it works for 2 digits, but what if there are more than 2 digits? I know that's just exactly what you were thinking, and I'm here to answer. What if we had to take on a beast of an equation like 456 times 23? I'd use the same model. I'd create a rectangle that's 456 somethings by 23 somethings. But now I might want to divide it differently. Can you see where I might want to do that? The easiest way to do this is to divide the length into 450 and 6. Still, the total length is 456, but these are easy numbers to work with. Sometimes people want to stick with dividing the number into two spaces, and they do 450 and 6, and there's nothing wrong with that conceptually. In terms of moving to the partial products algorithm, though, it's easier if you divide it by place. So the 23 width now becomes a length of 20 and a length of 3, and this now gives us 6 rectangles instead of 4. I'm going to think out loud a little bit to do this, because this is the way I want you to think. If I were doing 2 times 400, that would be 800. So 20 times 400 must be 8,000. I've put almost all the partial products in here, but I want to think about this last one, this guy right here, the same way we thought about this one. Again, because this is how I want you to think about these things. So I know that 4 times 3 is 12. So 40 times 3 must be 120. So 400 times 3 must be 1200.